Hello and welcome. If you've been bewildered by all the diagrams on the internet trying to explain Cognito or OAuth, then this is the place for you. I too have been utterly bewildered by those diagrams, and I have come to the conclusion that a diagram can only take you so far, and really you need to sort of understand the steps involved. So in this lesson, I'm going to walk you through the steps of an OAuth authentication flow. We'll look at this conceptually in this lesson, and then in the next lesson I'll walk you through the whole lot again, but looking at an example React application, and we'll see this happening in TypeScript code. There is a previous lesson in this playlist which is a sort of run up to this, so if you find this a bit heavy to start with, I'd recommend you just skip back a lesson. You can see details in the notes below. Okay, so with that we'll get started. So we'll just set the scene. Imagine you're a company and you've decided to allow people to log into your system using Cognito. So you've created a Cognito resource in AWS, and it's maintaining a database of all your users for you. And AWS will provide a Cognito login web page that your customers can connect to with HTTPS XXXX, AmazonCognito.com, where XXXX will probably be your company name. And when you originally created this Cognito presence, it would have generated a client ID. This is a sort of one-off generation, and all your software will be configured to know what that ID code is. So with that in mind, let's walk through the process for one of your customers to log in. We'll assume that they have gone to your company website. I'm calling it our website, .cloudfront.net, but this is where your company website is hosted. And at this place is a React application, and they're running the React application, and they click on a login button. So the code behind that login button will do the following. It will generate a random string. All my strings here are 8 characters long, but in reality they'd be much longer, but obviously this makes it easy to read. So they generate a random string and they would assign it to a variable called state. And then they pretty much do the same thing again. They generate another random string and they'd assign that to a variable called code verifier. And then your React application would call a well-known function SHA-256. SHA stands for Single Hashing Algorithm, 256 bits. So you call this very common function and you pass to it the code verifier, and out pops a string. Now, if you pass this value to this function, you will always get this string out. It's not time dependent, it's a pure function. And so anyone who has this number 70EZ can pop it into this function and they will receive RAZ out of it. But the reverse is not true. The algorithm behind this function is designed so it's as good as impossible to take this RAZ and apply some sort of mathematical transformation to it in order to generate this 70EZ. So it's a one-way process. If you know 70EZ blah blah, you can get to this RAZ. But if you know the RAZ, you cannot get back to this 70EZ. So let's just imagine a scenario where you and I meet up and I say to you, my name's Richard Bray and I'm going to give you a phone call tomorrow. I have a code verifier which only I know, and I've put it into this SHA-256 algorithm and it's generated RAZ07. So I give to you this RAZ code, and then tomorrow I phone you up and I say, here is my code verifier. And you take the number, you drop it into the SHA-256 algorithm, out pops RAZ07, and you compare that to the code I gave you yesterday. And so you now are very confident that I am the person who you met yesterday. This technique is essentially at the heart of how this entire flow works. So let's just do a quick recap. We generated this random string and put it into state. We generated this random string and put it into code verifier. We then take the code verifier, the 70, we drop it into the SHA algorithm and produce RAZ07 And we call that the code challenge that we're going to give away in a moment. But importantly, we now store the state and the 70, the code verifier, in browser storage. So our application can exit, everything can go, but when our application starts again, it can go back to browser storage and get these two numbers. Okay, so once we've completed the preparation, we now tell the browser we would like it to open a web page from a completely different website, namely the AWS Cognito website. And to do that, we essentially poke into the address bar https amazoncognito.com/login, and then we also, I've put this on multiple lines, but all of this is essentially one big address. The client ID is this, the code challenge is this, the code challenge method is this, the redirect URI is this, and the state is this. So all of this data goes into the address bar of the browser, and then we say to the browser, right, load this. So it visits the Amazon web server and this page is loaded, and when the application loads, its JavaScript can look at the address bar and read all of this, which is still there. So we've essentially left behind our website and we've now visited the Amazon website, and we've passed to the incoming Amazon application a whole bunch of data through the browser address bar. So at this point, the login web page appears and the user types their username and password. They hit the OK button, and now the AWS web page wants to return control back to our React application running at our website .cloudfront.net. So the AWS JavaScript program pokes our return address website .cloudfront.net/callback into the address bar, and in fact it then hands us some data in the same way. It also puts code equals 9AD4 blah blah and state equals 4DC4. So it puts this data into the address bar and tells the browser, I want you to go off and load this address. So it then redirects to our website and loads our application. So our application can then go to the address bar and read the data that's been passed back, the code and the state. So essentially we've been using this address bar as a data transfer mechanism. So the data transfer mechanism that's going on here is all by sticking data nice and visibly into the address bar, and it's not considered secure to hand back access tokens or ID tokens, the important tokens we need, by just shoving them into the address bar. So instead, the AWS JavaScript program has given us this code, and it said, look, if you come back to me with this code on a secure API call, then I will give you the real data that you want, which are these access tokens. So our React application is now back in business. It's loaded, been routed to this callback page. So it does a couple of things. The first thing is it grabs hold of this data from the address bar, and then it goes back to the browser storage and loads the data that we stored earlier on. It loads this state value, and it loads the code verifier, this 70EZ. So it compares the state that it received from the address bar with the state that it stored, and if they're different, then that is a red flag that something very untoward is going on, and perhaps the data's been interfered with, so it won't go any further. But provided they're the same, that gives it assurance that this is a secure connection, and it proceeds to the next stage, which is to make an API call, normally implemented with a JavaScript fetch or an Axios call. But this is a program API call directly to the Amazon Cognito server, and it passes the client ID and the code that was sent back to us here. And the Cognito server will remember the conversation, and we say, here's my code verifier. So we give it this 70, it puts it into the SHA algorithm and pops out RAZ, and it says, yes, that's the RAZ you sent to me in the previous conversation, so I'm satisfied who you are. I've got your code, I know the conversation you're referring to. I will now send you the data that you really want, which is your ID token and your access token, where the ID token will contain the user's email address and the access token will contain a list of what are called scopes, but these are essentially permissions to access further resources. And that completes the entire process. So that is my very best attempt to explain to you how this works. I apologize profusely that it's gone on for quite a long time, and I hope very much that you managed to follow it. If you didn't, you're probably not even here by now, but if you are, thanks for sticking with me, and I'll see you in the next lesson.